All right. So here is the question. Seems to be so big. Okay. An inclined plane making an angle of 25 degrees. Okay, making an angle of 25 degrees with the horizontal has a frictionless pulley at its top. So this pulley is frictionless, meaning that we don't have any friction here. A 30 kg block on the plane is connected. So it is on the plane. So meaning that this one which is here is 30 kg is connected to a freely hanging 20 kg mass. So it's one 20 kg and it's freely hanging by means of a light rope passing over the pulley. The coefficient of kinetic friction between A and A, now A is the same object. Like obviously, coefficient of kinetic friction can only be on that object which is on the incline. This is B. Okay. Like this B cannot be affected by friction because it's not attached to the incline. So every time they mention the friction, just know that it's the one which is on the incline. Now we have got coefficient of kinetic friction here, which is equal to 0.1, meaning that the incline has friction, but the rope itself, this pulley you are able to see, it doesn't have any friction. Okay. Now the distance. What's the question? Calculate the distance the 20 kg block will fall in 2 seconds starting from rest. Neglect friction. Can neglect friction. So what friction are we neglecting here? Or the friction that we are neglecting, remember we are mentioning the 20 kg object. So the friction that you might be neglecting here is the air friction, like the friction from the atmosphere, like that, which might be pushing the object upwards because when it is falling down, there will be such a force. Now, because we've been asked to find how far the 20 kg object is going to fall in 2 seconds, meaning that we're going to take the direction of motion as going down. Okay, meaning that the net force for this object going down is going to be what? I mean the net. So we're going to work out with these two objects. I'll start with the same one which is going down. The net force for it is moving in the y direction, is going to be mg. That's the force moving, taking it in the down direction, and then minus there'll be a force which will be pulling it up. That is obviously tension from the rope. Okay, net force is given by mass multiplied by the acceleration, that will be equal to mg minus tension. So where there is mass, I'm going to put that is 20. We don't know the acceleration, that will be equal to the mass again, that is 20. G is 9.8 minus tension. So I'll take tension, the other side of the equation becomes positive. So here we're going to multiply 1.8 multiply 9.8 multiplied by 20. That is 196. Since 9.8 times 2 is 19.6, and then we have got that 0, that would be 196. Yes, Martha. Martha, there's a question?
Sir, so
Yes.
you mean the angle there is not affected by anything?
No, I haven't yet started talking. Like this 20 kg object, it's not on an angle. It is just in the y direction. So the angle won't affect it.
Oh, sir, sorry. I thought you were talking. Okay, miss.
All right. So you can now go to the one which is on the incline. Okay, now since this other one is dropping, meaning that this one is going to be going up. Now remember we have got friction on the incline. Friction is going to act in the opposite direction, right? And by reason of this being on an incline, what other force is supposed to go down? Martha, what other force is supposed to go down by reason of this being on an incline?
FG, sir.
Yes, we have Fg. So Fg is because of the incline, but Fk, that is kinetic friction, is because motion, like this object is moving up like that. So Fk obviously acts in the other direction. It's more like an enemy of progress. So you look now at the net force index direction for the mass on the incline. You get the force going in the direction of motion. That is obviously what is pushing it is the tension in this force. Okay, and then remove all other forces going in the opposite direction, that is kinetic friction and also Fg. Net force, we know that is mass multiplied by the acceleration. And then we have got tension minus Fk, we know that that is mu k mg cos theta on an incline, right? There's a question.
Yeah. How are we getting the tension minus what and what are we?
Okay, so like you are looking at this object A, and you know that it is moving going up. So you look at the forces which are pulling it up. You only have tension in the rope, that is T, which I've labeled. And then look at the forces which are going in the opposite direction. You have got kinetic friction. You also have Fg. So those are the forces which are going in the opposite direction. So that is what is going to give you the net force. You get the force going in the direction of motion, that is the tension, minus the forces which are opposing motion, that is kinetic friction and Fg. Is that okay? Okay, and we know that Fg is given by mg sine theta. So I'll start substituting. The mass for this one is 30 multiplied by the acceleration, that is going to be equal to tension minus mu k, that is zero point 0.1. The mass is 30, g is 9.8, and then cos, the angle of the incline, that is 25, minus mg. Okay, mass again is 30, g is 9.8, and then sin, the angle of the incline, that is still 25. So this is going to be 30A being equal to tension minus, now just punch this direct on the calculator like together. I'll say negative zero point 0.1. Please, if you can't punch them together, work with them stepwise. Negative zero point 0.1 multiplied by 30 multiplied by 9.8 multiplied by cos 25. So just that will give us negative 26.65. But I'll continue. Minus, we have got a 30 multiplied by 9.8 multiplied by sin 25. So that is giving something like, let me also again punch it just one more time. Instead of just punching directly, let me first write what I found here so that I'll not confuse anything. That is negative 26.64544. Then minus, so I'm going to say 30 multiplied by 9.8, and then multiplied by sin 25. So that has given me 124.2497. So this will become 30A being equal to tension minus also negative 26.6454544 minus 124 point. So that's value that we have. Let's see what we get.
Yeah, I can't see what you're writing.
Is it the case with everyone? You all can't see what I'm writing?
So was the
Can't
last
see.
thing that you wrote 30A minus is it or 30A is equals to tension minus?
Yes. So I've just written 30A is equal to tension minus. So the value I was punching, this will give us 150.895211789. Back then I still can't see. Okay, so that is what we are going to get. Now the next thing from there, I'm going to make tension also subject the formula. So if we make tension subject the formula, we're going to have tension being equal to, I'll take the negative 150 the other side, so it becomes positive 150.895211789, and then plus 30A. This is going to be equation 2. Now, friends, this is the same rope. This is tension. This is tension. It's the same thing. Like tension is the same. This is the same rope. So equation 1 has got tension is equal to, and equation 2 also has got tension is equal to. So we're just going to equate these two equations because they are all equal to tension. Okay, they are basically the same. So that is going to give us, I'm going to get equation 1, that is 196 minus 20a, equated to equation 2, which is 150.89521.789 plus 30a. Okay, I'm going to get this 20, take it the other side. It's going to become positive 20. It adds with a 30. So 20a plus 30a, that is going to be 50a. And then I'm going to get this 150, take it this other side, becomes negative. So that is going to be 196 minus the same 150. That will be about 45.104782. Divide both sides by a 50. That is going to give us about 0.9020956. This is acceleration, this is meters per second squared. So if the question was also asking for the tension, you can use any equation. You can come in this equation, just substitute where there is acceleration, you put the value that you have found, then you'd have found the tension. You can as well use the second equation. It doesn't matter which one you use, the answer is going to be the same. So since this question is asking us now that we have found the acceleration, we can now calculate the distance the 20 kg block will fall in 2 seconds from rest, meaning that it is coming from a velocity, initial velocity of 0. And then we know its acceleration is zero point 0.9. We know the time it will take is 2 seconds, but we want the distance is going to fall. That is the height. And you know that 2GA. If I say 2GA, someone might be confused. Let me say 2AS is equal to V squared. Again, I'll not use this equation because we don't have the final velocity in this problem. So what I'm going to use is height or distance is equal to ut plus half at squared. So this will be height is equal to initial speed. You've been told it comes from rest, so that is 0. Then plus half. The acceleration is what you've just determined. So never use acceleration due to gravity. Don't use g here because this object is not freely falling. It has been attached to a rope. Okay. So the time which is going to fall is 2 squared. We know 2 squared is a 4. 2 there is 1, 2 there it is a 2. So all we are going to do is the value that we have here will multiply by 2, 0.9 multiplied by 2. Therefore the height or the distance that is going to fall is going to be 1.804 meters. So if this is the height that this object has fallen, that means it's the same height that this object has risen. So that is how you are able to calculate this question.